Hey guys, BuildZoid here, and today I'm going to be doing a demonstration of why too much LLC, like why setting, like maxing out your load line calibration is bad for your overclock stability. So I'm using the Gigabyte Z490 Aorus Master. Thank you, Gigabyte. I have the 10700. I have a 10700K. Thank you, patrons, for funding the purchase of the 10700K. Yeah, right now we're just going to run Ultra Extreme LLC, which is the highest level of LLC available on this motherboard. So we have 0 Vdroop. There is no Vdroop when you have Ultra Extreme LLC. I've not adjusted the Vcore VR, like the switching frequency, because it doesn't really do anything. The current protection is maxed out. The voltage protections are maxed out, because where we're going, we don't really need any kind of protections. We're not doing anything particular, like we're not doing anything dangerous. For the core voltage, it is set to 1.23 volts, and the CPU is set to run 5 gigahertz with 4.3 gigahertz cache, along with a memory multiple, and the memory is running 3466 CL16 XMP. So those are our settings, and now we're just going to get into Windows, and we're going to be running a little bit of Prime 95, 32K FFT size, because I've determined that it's the most reliable way of doing this demonstration. Capture cards being a bit silly. Give me a second. There we go. That's much better. So now we're going to open up our Prime 95 and hardware info and core temp. So core temp is what we're going to actually use for the temperature monitoring, mostly because I'm going to be scrolling all the way down in hardware info to our various voltage sensors. So on the Z490 Aorus Master, if you're using an up-to-date version of hardware info, the Vcore voltage sensor you should be looking at is VRV-out. VRV-out is the voltage measurement directly from the silicon of the CPU itself. So this is the most accurate voltage measurement in your entire system, at least for Vcore. So that's by far the most accurate voltage measurement, and that's the one you should be paying attention to. That's the sensor that the actual voltage controller is regulating against. So with Ultra Extreme LLC, this voltage should basically be constant, 1.23 volts, plus minus a little bit of error margin because nothing is perfect. So we're going to go and set, our 32K FFT size. And we're just going to run that. And as you can see, we have no Vdroop. Now, the Vcore sensor of the Super I/O on the motherboard, which measures the voltage from the CPU socket, like from the back of the CPU socket, that's reading a voltage increase because there's a bunch of impedance between the CPU socket and the actual silicon of the CPU, also known as a CPU. The CPU socket itself. Pins are actually like pin contact to the LANs on the CPU. Not really that great for transferring power, turns out. And I do have some content planned around that in the future. Anyway, so as we can see, VRVR, is sitting around 1.23 volts, which is correct with Ultra Extreme LLC. CPU is running at around 78 degrees right now on the hottest cores, and we are running Prime 95 with AVX. So this is very hot. Like we are pushing almost 200 amps into the CPU. This is a very very stressful workload that we're running right here. And the CPU is cooled by a 240 millimeter AIO. It's also delidded and there's liquid metal under it. So, there's liquid metal instead of solder on it. Yeah, though I didn't delid the CPU for the temperature improvement, I delidded the CPU for measurement purposes. But, we'll get to that very soon. But anyway, so this is running right now, and now I'm just gonna crash this by moving the mouse around, opening the Windows menu. Might take a while before it locks up. We might lose some threads, but there we go. So yeah, we just lost a core, as you can clearly see there. So this is not stable, right? We just lost a core. So core 3 is probably the weakest core on the CPU. So if you were messing around with the hyper-threading disable option that you have on the modern 10th gen Intel CPUs, like the CPU core I would disable as core 3 on this. So we're going to enable. And core 3, I shouldn't have been moving the mouse while Prime 95 was starting. It just immediately lost core 3 again. Core 3 sucks. Come on, core 3. Let's get to full load. Okay, so core 3 is now happy. And then I'm going to start moving the mouse again. And I wanted to outright, blue screen lock up, crash hard. Not just this lame, oh, you lost a couple threads. and I'm not gonna get it to do that. I like the thing is the stability is a little bit tied to the operating temperature, so if I just let it warm up a bit and then start moving the mouse around, this would actually be working a lot better, but I'm trying to keep the video short. So, and as we all know, I have a policy of not editing because well, let's put it this way. I don't trust myself to ever, like, if I decided to start editing my videos, there's a pretty good chance I would never actually upload anything because I would spend so much time fiddling with, like, editing stuff. So I don't edit because that's the only way to reliably get videos posted. Anyway, okay, let's start moving the mouse again, please. No, we just lose a bunch of threads. This is super annoying. This motherboard's too good. Like, there's a different motherboard that would pretty like, there are other motherboards where this would pretty consistently just crash outright, but this motherboard's pretty good about, like, just not completely dying, which, you know, for the purposes of this demonstration is actually really annoying. But the other issue is, like, there's a lot of motherboards where you can't get access to this sensor. And we just lost core 3 again. Okay, I think the point, you know, I've proven my point. Like, this isn't stable. You shouldn't be losing a worker like, you shouldn't be losing workers all the damn time in Prime 95 as soon as you move your mouse. That's not okay. You can't consider that a stable overclock, but, all right, well... Can we please, like, outright crash? Like, it's really annoying. Like, sometimes I can get it to crash in a couple, like, properly crash hard in a couple seconds, and then the rest of the time I get this. It's like, okay, we'll just, you know, not stable. Like, it's constantly losing workers. You can't consider that a stable overclock. I was really hoping to get a blue screen, mostly for dramatic effect, but, yeah. Well, we'll have opportunities to get blue screens instead. So at this point, you're probably thinking, it's obviously we need more core voltage, right? If the CPU is not stable, we need more Vcore. Well, yes, but actually, no. So I just set so, you know, during this whole time, it's been running at basically 1.23 volts constantly. But now I set it to 1.36 volts, but with medium LLC. And medium LLC has a lot of Vdroop on it. So we should still end up running around 1.23 volts again once we get under Prime 95. But this time we won't be randomly losing workers all the damn time. There we go. Capture card finally decided to work. On core temp, hardware info. Right, so we're going to do small FFTs custom, 32K, 32K, and we're just going to fire that off. And now I'm so confident in this that, you know, I'm going to scroll around in hardware info, which actually isn't as nasty as just freely moving the mouse around, which is kind of funny. But, yeah, Windows has some weird interactions when you just drag the mouse around the desk. Like, if you're just flinging the mouse around for no reason, without manipulating anything, for whatever reason, that actually has some weird interactions with the operating system that you don't get if you're actually, like, dragging a window around or anything. But anyway, so yeah, our core voltage now is like 1.229 volts, 1.227 minimum. You know, as the CPU warms up, it's going to pull more and more current, so that voltage is actually going to slowly climb down a bit. And, you know, I can flick the mouse around as much as I like, and this isn't going to lose workers. I should have probably set a timer previously for how long it took me before a worker crashed, but, yeah, unfortunately, I didn't do that, so here we are. All right, 80 degrees, still, you know, still running. And honestly, I think like, if I let the loop warm up. Actually, you know what? I'll just disconnect the fan on the AIO. It's on a 240mm AIO. I'm gonna disconnect one of the fans. Which, like, the main thing is I don't want it to cool down too quickly when we go back into the BIOS so that I can crash it again when we switch to Ultra Extreme LLC. So, yeah, you know, this isn't going to go anywhere. Like, yeah, now we're at 82 degrees, still stable. Voltage is now 1.226 volts with a minimum of 1.225, and Nope, no crashing. 83 degrees, yeah, so removing that fan actually made quite a difference. Which is what you'd expect, because when you, like, if you're using a 240 millimeter radiator and you only have one fan on it instead of two, the, like, the fan that, well, I still have two fans, one of them is just turned off. The thing is, you're actually leaking airflow through the, like, the powered off fan. So the fan that isn't spinning, that one's actually losing a bunch, like, you're losing a bunch of air pressure to it. So there's less air actually passing through the radiator, even under the fan that is still turned on, which is kind of annoying. Anyway, so yeah, 87 degrees, as you can clearly see. This is way more stable than before. And I'm actually going to plug this in, because I don't believe that the single 120 on its own is enough for the CPU cooling. There we go. So now I'm just going to... We're just going to restart. We're going to switch to Ultra Extreme. I've unplugged one of the fans again. So now we're going to go back down to 1.23 volts. So as you saw, you know, we were, like, the VR Vout sensor under when Prime 95 was actually running, we were reading 1.23 volts. And it wasn't crashing. I was still moving the mouse around. It was perfectly fine. And now we're going to run Ultra Extreme. I'm actually going to keep the fan unplugged. Yeah, because, like, it went all the way up to 87 degrees when I unplugged it on medium LLC, and it was fine, right? And honestly, with Ultra Extreme, I'll be surprised if we get past 83 without it crashing hard. So let's open up Prime 95, hardware info, core temp, you know, get all our stuff up and running. We're going to scroll down to VR Vout again, so that we can see, and, you know, 1.228. So previously, I think the minimum voltage reading dropped down to like 1.225, maybe even a little bit below that. I'm going to run 32K, fire that off. And yeah, we're a little bit under 80 degrees, but because there's now just one fan instead of two, it should ramp up pretty quickly, I hope. It's not doing that. I'm just 81. You know, still like minimum voltage 1.226. 82. So I'm going to start moving the mouse now, and we immediately lost core 3. So core 3 is again extremely upset, right? Like as soon as I started moving the mouse around, core 3 just went like, nope, we're not doing this. I'm done. I'm done with this. I'm not running Prime 95 anymore. So I'm not gonna touch the mouse now. I'm gonna let it get up to 85 degrees, and then I'm gonna move the mouse. And in theory, I would expect that to just hard lock the system at this point, but this motherboard has so far been not failing to disappoint me with its ability to crash. Core 3's gone again, which that's great, but it's like I wanted the blue screen, damn it. This is not okay. And funny thing is, I was pre-testing before trying to shoot this video, and I was having no problems getting it to lock up hard at like 81 degrees, and now it's like, nope, turned on the camera. I'm not going to blue screen. You've got to be kidding me. Anyway, but you can now see that Core 3 is very, very upset about something. But what's it upset about? The Vcore is still reading the same damn voltage, right? Like, oh, like, what's the problem? Well, actually, since we haven't crashed, like, there goes. Like, I actually have a few failed takes of this video at this point, so I was already going through the routine from a failed take. But so here's what's going on that we can't see in the monitoring software in Windows, and I'm gonna plug in both fans now because I'm actually kind of upset that the CPU 86 is not that hot. That's fine. Like, oh yeah, there you can see what moving the mouse does, right? So we're just gonna. Like, I'm actually going to stop Prime 95 for a little bit. Like, the loop shouldn't cool down too much. So, you know, what we're seeing on the oscilloscope right now is the actual core voltage reading from the substrate of the CPU. So not the actual die sense, which is why that voltage level was higher than it was, you know, than it is on the die. It's just there's a bit of impedance between the measurement point I'm at and the actual silicon of the CPU. So that's why the measurement isn't completely spot on. But here we can see a lot more detail in terms of what's happening because the oscilloscope picks up on things that no monitoring software can pick up on, like the spikes that we're seeing just sort of all over the place right now. So by that I mean these spikes right here. And I just realized my horizontal isn't centered. So like these spikes right here. And so these spikes are actually the Windows event timer, which I actually now have the utility for that thing. So here's our timer tool, and bam, right? So, and if I adjust that up, we have less, like, there. And this is just like how Windows, I forget what it's meant for, but it's meant for like timing events in various like applications and that kind of thing. So like video playback applications will crank up you just saw the little notification. It just cranked up the notification that popped up with the firewall. It just cranked up the event timer to, I think 0.5 milliseconds or whatever. And video playback will do a similar thing, so that kind of thing. But we can't see the spike anywhere in the software, right? Like, no monitoring software is telling us, hey, you've got a pretty massive voltage deviation just kind of happening. And the reason for this is the software is simply not fast enough. And in fact, most of the sensors in your system aren't really designed to be fast enough to pick up on this kind of stuff. Now, the interesting thing that happens when we run Prime 95 with 32K FFT size is, so we're running Prime 95, and you can still see the event timer spike, right? That's the upward spike that we see over here, right? Like that's this spike. That's still the event timer spike. And basically every, 15.625 milliseconds, like it ticks along at 64 hertz. In a previous video, I made a mistake. I think I've actually made that mistake in several videos where I say it ticks along at 16.25 milliseconds by default, but no, it's 64 hertz, so it's less than 16 milliseconds. But anyway, I don't actually care about that. Like, the thing is, I don't care that much at what rate it is. It's just like that spike is normal. That's just Windows doing Windows things. Now, when you're running Prime 95, the spike goes upwards instead of downwards because when you're sitting idle on the desktop, your CPU isn't doing anything, and then Windows goes, hey, could you, like, event timer, we need to check if there's anything to do. And that, is basically a spike of activity on the CPU. It runs a bunch of instructions, so the CPU pulls a bunch of power, and we get that voltage spike downwards because suddenly you need to put, like, the CPU suddenly pulls in a bunch of current when previously it wasn't pulling anything. Now, when we're running Prime 95, we're pulling 200 amps constantly until the Windows timer goes, hey, stop running Prime 95, and we get that upward spike. Because it stalls out the workload, so suddenly all of that current that's going into the CPU has nowhere to go, and it translates into that upwards voltage spike. Now, this is called overshoot. When the spike goes downwards, it's called undershoot. And we're not really like, well, if the spike, like, yeah, if the spike is going downwards and we're like going below our target voltage level, it's undershoot. If it goes over our target voltage level, it's overshoot. And overshoot really not a concern from a like overclocking stability perspective. It might be a bit of a like CPU lifespan hazard if your motherboard is especially bad. If you have a motherboard that's actually good, like these spikes don't get very tall unless your motherboard is really, really crap. And I have tested some incredibly crap motherboards where I've seen like upwards voltage spikes going into the 1.7 volt range, which was concerning, but the CPU still survived even that, because 14 nanometer Intel chips are very, very tough. But yeah, the downward spikes are really bad for your stability. Now, the spikes we get when I move the mouse around, those are even more extreme. And, oh, there we go. Now I got the blue screen. I didn't want it now. I wanted to capture one of the damn spikes. Why can't you do the... It's the curse of having a camera turned on, right? If you're not trying to record, it's going to do exactly what you want. And as soon as you start recording, it does the opposite. Because right now, it would have been really convenient if it didn't just crash the moment I touched the bloody mouse. Though, admittedly, that was mostly because I let the CPU warm up a lot. So, anyway, we're going to open up Prime 95 hardware info. I've plugged in the second fan again, because this time I would actually like the slight increase in stability that we get from from having the CPU cooler. So I'm just going to run small FFTs. We're going to scroll down. Actually, I don't know why I'm scrolling down. There's no point. We've already seen the VR V-out sensor. You already saw what's going on with that, where, with medium LLC, we're stable. But we're going to, I know I didn't want small FFTs. I wanted 32K. 32K specifically is really bad. I mean, this looks really bad as well, but it's actually not. It's not anywhere near as hot. 32K is a... like for this demonstration, it's a very convenient workload to use. So we get those nasty downward spikes, and I'm just going to capture one with, put the scope in single mode, and there we have one of the spikes. Hopefully this is it's not a good looking one. There we go, that's a better one. But can I, that is the perfect spike. That is exactly what I wanted. Now we're going to take a look at this thing in detail. So I move the mouse, right? And Windows freaks out when you move the mouse. I don't really know why. For whatever reason, if you actually like grab a window or you're manipulating something around the screen, these spikes are actually they don't exist. I think it's Windows trying to predict what you're about to click on, and for some reason, like it's dumb, but yeah. Theoretically, you could also have an application that has this kind of behavior just built in as part of its programming. Maybe a game has a weird way of handling inputs and also has really heavy physics calculations using AVX, and you could maybe get something like this with that. So, yeah, or you could just have a game that uses AVX for, like, I don't know, decompressing files or something, and if you're on a loading screen moving your mouse, it'll crash if you're as it's decompressing the files. But anyway, so we're running Prime 95 here, right? Before the upward spike, right? This section right here, this is just Prime 95 doing its thing, Prime 95 doing its thing, and then we get that upward spike. And that's Windows going like, oh my god, the user moved the mouse. What is he about to do? What is he about to do? And then Windows does some stuff. And we can clearly see that the stuff it's doing pulls less current, right? It's pulling less current than Prime 95, because the voltage level right here, it is lower than right here, right? If we move the trigger around, this is hovering around sort of the 1.28 volt range, whereas this part right here is more like 1.24 volts. So there's definitely a decrease in current draw going on here, and Prime 95 might have gotten pushed into the background a little bit, so it might still be running there, but ultimately I think that's mostly Windows doing stuff, and that stuff is at less current draw than the Prime 95 workload. Now, the problem comes along, and so far everything's fine, right? Like, there's not really a big deal, because if we're not running Prime 95, like, during this, we're not doing as much work, so the CPU is not under as much load, it's less likely to crash, and we're not that concerned about that. But the problem comes along when we get to this point, right here. And the problem right here is that now what's happening is Windows has, sort of gone like, okay, I've done my prediction of whatever, like, done my crazy mouse handling stuff. And now it's time to start Prime 95 up again. And Prime 95 pulls, in the background you can see in hardware info, Prime 95 pulls a lot of current. So if we go from pulling less current, so we're on ultra extreme. I have it set to like 1.23 volts. I would assume we're probably pulling less than this part right here, I would expect that to be pulling less than 100 amps. So if you go from pulling less than 100 amps to suddenly pulling almost 200, you get a downward voltage spike, because the VRM literally, actually, like, it's not even the VRM. You could have a crazy fast VRM. Ultimately, you still have a power plane in front of that. Like, there's not much you can do about this. So you get a voltage spike downwards because physics sucks for basically everything you want to do, right? You want to go to space, physics screws you over. You want to regulate the voltage to a CPU while it's pulling varying amounts of current, physics screws you over, and you get a big fat downward voltage spike. The problem here is, at this point, at the bottom of that point, Prime 95 is already running, right? It is running at this point. And that voltage is a lot lower than what it normally needs to run. So this right here, that bottom of that spike, is what crashes out Prime 95. Right? That's what causes the calculation errors, because for several clock cycles, as we're running our AVX instructions, our CPU isn't getting the voltage necessary to run at the frequency we're trying to run. In this case, 5 gigahertz. And so, yeah, that's why when I'm moving the mouse around on Ultra Extreme LLC, This is what's causing it to crash on Ultra Extreme LLC, but this does not explain why Medium LLC is more stable. Anyway, I did also want to demonstrate that if I grab a window, the spikes go away. So right now we're at 10 milliseconds per division on the oscilloscope, so I'm going to put the trigger out of the way. So if I just move the mouse, we get the downward spikes, right? Yeah, good. I'm going to grab our, core temp window, and spikes are gone. So yeah, Windows freaks out if the mouse isn't actually doing something, which is interesting to say the least. Like that is, very bizarre. And you can see the Windows like freaking lagging and everything, but nope, there's no downward spikes there. But as soon as I let go of the window, downward spikes. But grab the window again, and Windows stops freaking out for some reason. So that's very strange. The funny thing is, though, like, ultimately, what is causing the transient to me doesn't really matter that much. The fact that the transient exists, like, there's a basically, the fact that Windows can cause this is, like, there is a software scenario where some software could cause that kind of behavior, and it'll cause instability. So you don't want your CPU, like, you don't want your core voltage set up in such a way where, you're going to have problems with, random blue screens whenever you move the mouse. Or, the software might just randomly do some weird multi-threaded schedule. Like, it might manage its workload in a weird way where it suddenly jumps from not pulling much current to pulling a ton of current, and then you crash. Which is what happens when I move the mouse. But there's other scenarios that can create the same thing. It's just that for my purposes here, this is the most convenient demonstration that I've come across. Anyway, so if we bump this up to 1.36 volts and we run medium LLC instead of ultra extreme, the stability improves massively, and this is for a very simple reason. So now, when we're pulling less current, the core voltage goes up. And this means that ultimately, like, we can't actually do anything about that downward voltage spike, or the upward voltage spike for that matter. Like, that upward voltage spike is directly proportional to, the design basically is entirely dependent on how is the VRM designed, how is the power plane designed, what kind of capacitors are used, where the capacitors are located, how are they connected, that kind of thing. But there's not really, like, there's nothing you can really do as a user to like adjust that upward spike behavior. So that spike just is a feature of your VRM, and there's not much you can do about it. For a given amount of current, for a given change in current draw, so going from 200 amps to 50 amps, you're going to get a spike of X. And if your VRM is better, that spike will be smaller. If your VRM is worse, you're going to get a bigger spike. Same goes for the spike in the downwards direction, where if you're going from 50 amps to 200 amps, well, you're going to get a some size of spike. If your VRM is better, the spike's going to be smaller. If your VRM is worse, it's going to be bigger. If if the change in the current, if you go from 100 amps to 200 amps, the spike will be smaller as well, assuming the VRM is the same. So we can't really do anything about the spike, because it's just tied to sort of, the scenario and the physical capabilities of the voltage regulator. But, yeah, so now we're going to run 32K, but with the medium LLC. Right? And you'll notice, so our voltage, instead of going up, has gone, like, down, right? Previously, at idle, our voltage would go down because, again, there's impedance between my measurement point and the CPU like the actual silicon of the CPU. And now we get, like, this looks right now about the same as when we were on, like, as long as I'm not moving the mouse, this looks exactly the same as when we were on Ultra Extreme LLC, or at least it looks like that to me. I've not actually, like, honestly, I could have noted down the statistics that I have running along the bottom of the oscilloscope screen, but yeah, didn't really think that through too much, did I? Anyway, core voltage is reading like 1.29 volts, or all of our cores are pretty happy. But when I'm moving the mouse around now, you'll notice, yeah, we're still getting those spikes, but they don't go as low, right? Yes, they still go below our average voltage, but they don't go anywhere near as low as they were going before. And here's the reason for that. So I'm going to set the trigger. I'm going to zoom in a bit. Going to capture me a spike. And I realized that the horizontals all screwed up probably. Did I set it too low? There we go. So, actually, oh man, I nailed it. This is a really good one. So, as before, right, if we scroll through this, we have Prime 95 doing Prime 95 things. for the initial part. Then we get to the spike here, which is Windows going like, oh my god, the user touched the mouse. Stop everything. I need to like predict what the user is about to click on or something. And that's the whole like I'm assuming that's what Windows is doing. I don't actually know what it's doing. It's just like, that's the only thing I can think of. Because otherwise, like, why doesn't... Because if it wasn't for that, like, if it wasn't trying to predict what you're about to click on, why, if you're actually, like, manipulating a window, do you not get the spikes anymore, right? That's the only reason I can think of, is just, like, they're trying to predict your input or something. Anyway, you get this, you know, so we get this low current workload over here because, you know, first we get the stall out spike, which... there's nothing you can do about that. It's always going to be, like, the height of this spike is just dependent on the change in current draw. But then our voltage levels off at a higher level than Prime 95, right? Like, Prime 95 was, again, running at around that 1.28 to 1.29 volts. But then the Windows doing Windows things is running at around 1.32, 1.33 volts, right? So, actually, well, 1.31 to, like, 1.33 volts. So... at a higher voltage. And what that means when we get over to the downward spike is, well, now our downward spike, the height of this should be basically the same as when we're at ultra extreme LLC. The height of this spike should be basically the same. However, because we have shifted our spike from starting at, previously it was starting at like 1.24 volts and dropping down to like below 1.2 volts, that was really bad for stability. It was bottoming out really low. And at this point, like already in this area, we're running Prime 95. Like that's the whole reason why we're getting that downward spike, is this is Prime 95 coming back to full current draw. So we are running heavy instructions and we're running a lot of them. And so we need the voltage, because otherwise we're going to start making errors in the calculations. Now, the thing is, since we've shifted the initial starting voltage up significantly, right? We've gone from 1.24 volts initial voltage up to around 1.32 volts initial voltage. Well, our spike is now going to drop the same amount of distance, but it's going to bottom out at a higher voltage because it started at a higher voltage. So this is basically like, if you're following a car, right? We can think of the CPU as the car in front and the VRM as the car behind it. If the CPU decides to brake check the car behind it, there's sort of two ways we can make sure that the car behind, like the VRM doesn't crash, like the VRM car doesn't crash into the CPU car. And one is we could make a better car, right, where it's better at braking, but that's very expensive and very difficult. Or we could just have the VRM drive way behind the CPU car. So when the CPU car decides to slam on the brakes, we've got plenty of time to respond. And that's essentially what the extra Vdroop is doing. Because we're sitting at a higher voltage, when the load hits, well, the hit isn't as hard, right? We have more time to react to it because we're starting at a higher initial voltage. So the stability's better because, you know, yeah, our actual average load voltage is exactly the same. Our power consumption is basically the same. Our operating temperature's the same. But our stability is much increased because now our minimum voltage while running Prime 95 is significantly higher. So we're no longer in that scenario where we have a bunch of clock cycles which aren't getting the necessary voltage to not make calculation errors. So, yeah, and that's what's going on with this. Oops, what did I press? That's what I get for not looking at the scope's UI. Press the help menu. How do I get out of here? No, that's not what I wanted. Okay, there we go. I wanted to run again. So, yeah, that's what's going on with the spikes here. I wonder if we can get one normally around. Yeah. Not normally that low. There. Well, anyway. So, yeah, that's why you shouldn't use Ultra Extreme LLC. And you honestly shouldn't even use Extreme LLC or Turbo. Even medium here isn't actually ideal. So the interesting thing is Gigabyte, for their Z490 motherboards, added a new voltage mode. And I do realize this video is now over 30 minutes. But I think the new voltage mode is really cool. So we're going to take a look at it because it is really cool. Okay, horizontal centered. So right now we're in fixed Vcore, and we're going to switch over to override Vcore, and we're going to go 1.3 volts. Now this is some, like, override Vcore, as far as I'm aware, is Gigabyte has basically done so, like, it's some, like, it's, I don't know how to describe it, but basically it's like a not stupid version of adaptive Vcore, as far as I'm concerned. So I like Override Vcore because Override Vcore is super convenient to work with. So we're going to just punch in 1.29 volts. Like the thing with Override Vcore is you do have to you're going to have to dial it in. And for your LLC, if you're using Override, you have to use standard. If you start using, well, okay, it's not true that you have to use standard, but if you start using the higher LLCs, there's no benefit to using override mode, and you should just, like, you shouldn't adjust LLC. Auto, normal, standard are fine. Anything other than that, not fine. So that's why we're using standard LLC. We're going to punch in 1.29 volts. And this is actually dynamic voltage. Like, this is some form of adaptive voltage, except Gigabyte has tuned it so that it actually matches your super I/O voltage reading, which I'm really not sure how they did that. But it's really cool because, like, for once, there's an adaptive mode that isn't a complete pain to set up. Because on Z390, I messed around with adaptive mode voltages because a bunch of people were telling me, like, oh yeah, you get way more stable overclocks. And I was like, well, yeah, because you can run, like, essentially, if you spent enough time with it, you could get the same effect that override mode has, where you can run, you know, full Vdroop, and so not get any, like, voltage regulation problems. But it took forever to get you'd have some weird overvolt, like your voltage would go up and down based on AVX loads, and it was really annoying in my opinion. I didn't like dealing with it, and so I wasn't a fan. But this thing is great because we're just gonna punch in 32K, and Vcore is reading 1.284 over it. I think I set it a little bit low. Yeah, I did set it a little bit low. You know, we're getting 1.226. Actually, no, I pretty much nailed it, right? So we're getting about the voltage that I wanted. Actually, it looks like we are a little bit low. But now, right, the crazy thing is we don't get downward spikes at all. Like, when I move the mouse, it just goes up. It doesn't go down anymore. So now our we literally, like, the whole issue with Ultra Extreme LLC was you got that massive downward spike. With medium, you still get a downward spike. It's just nowhere near as big, so the stability is a lot better. But in override voltage mode, it's gone. Like, there's no downward spike because this has full Vdroop, and I think ultimately, I think if we look at our vid reading right now, okay, no, the vid reading is not like okay. That's not what I was hoping for. So yeah, I'm still not, like, I don't know how Gigabyte implemented it, but it is so cool in my opinion. Like, and if you disable all your power management, it actually behaves like static voltage, which is great in my opinion. Like, for the sake of overclocking, like, consistency, having no power savings running is super convenient. So yeah, I am really, really impressed by override mode because this is insane. Like, there is no undershoot whatsoever. Right, so I'm just gonna try capture and, well, okay, wait. I'm gonna get one of them. There, right? There's our mouse do like there's no downward spike. Right? There, like, Prime 95 comes back under load and it's just nice and controlled return into load. There's no undershoot. Like, you don't even really have any overshoot, right? Because again, you're on full Vdroop. So basically, if well, like, yeah, the voltage goes up and that's annoying, but like, there's no like, it's not actually going beyond what the VRM is told to aim for, which is why you don't get that, like, returning to a lower voltage level of, well, you still kind of get that, but not anywhere near as much as without override mode. So override mode is just super freaking cool. Like, this is awesome. Like, this is so much more convenient to work with than adaptive mode, and you get all of the benefits that adaptive mode ever offered. Because, like, you could dial, like, on Z390, if you spent enough time messing with adaptive mode, you could get this effect. It was just really, really fiddly to get it into this condition. across like a bunch of different workloads and have the voltage be consistent, because adaptive mode would like I'm not a fan of adaptive. Let's just put it that way. And I've not been a fan of adaptive voltage for a very long time, but this right here, I'm a fan of this. Like this is just like, look at the voltage regulation. It's amazing, and it's it's me proof, is one way to put it. Which, to be fair, is pretty idiot proof. And if we run Cinebench, right? Like I think Cinebench would actually end up running at a lower voltage. Oh no, wait. Yeah, no, actually it's running at still a similar voltage. Like it's pulling way less current, and it's not running like that is the thing, is like I don't want the voltage going up when I'm running an AVX load. I don't want the voltage going down when I'm running to be fair, Cinebench R20 is an AVX work. Oh no, this is R15. So that's not even AVX, right? So what I really like about this is just like the voltage behavior is super consistent. Which is just like why I didn't like adaptive mode, because it was just like the voltage was going all over the place depending on what you were running, and it's just like, no, that's really annoying to deal with. But now like you just have to go through, like, you set it to override mode, and then you just walk the voltage up. You leave your LLC on standard, and you're golden. Like, this is freaking awesome. I'm so impressed. Like, it just doesn't make mistakes. It's incredible. Right? Like, this whole time Hardware Info's been running, and it hasn't picked up anything lower than 1.21. And actually, even on the oscilloscope, we've never seen the voltage go below 1.23 volts, which I'm very happy about, because, yeah, like, the thing is, if you have, like, full adaptive voltage with, like, idle power savings, like, sometimes you will run into scenarios where that actually causes instability, so that's why I'm a huge fan of, like, this is technically some implementation of vid, like, they've done something with the vid control of the CPU. So this should still be, well, actually, if we enable all the power savings, it's full dynamic, voltage, which I will show you. But the thing is if you disable all the power savings, it's basically like static voltage without the downsides of, like, because the thing is, if I wanted a load voltage of, for 1.23 volts with medium LLC, I had to have a fixed voltage of 1.36, right? With this, I don't need to set the voltage that high to get the appropriate voltage level. Like, if I punch in 1.35 volts, which is basically, actually, that's not going to be as high as I want. I'm going to go up to 1.4. But the other thing I wanted to show you is, like, if I re-enable EIST and I enable C states, then we're actually going to get power savings. I think. There might be something I'm forgetting. So we just went from 1.3, so we should be getting like 1.32 volts under load now, which is pretty close to about as much voltage as I'd ever run on one of these CPUs. Oh yeah, so there. Like, the voltage is literally so low we can't see it on the oscilloscope, because there's your full power savings. Like, we are idling super low voltage right now. Right? Like, the trigger is currently at 1.32 volts. And our voltage is somewhere down there, which, yeah, you get full power savings. And then when you move the mouse, obviously Windows has to wake up the CPU, and you go back up to full voltage. So anyway, now let's run Prime 95. This is going to get really hot really fast. The AIO is not quite big enough for this much voltage on an 8-core like this. The funny thing is, your idle power consumption, even if you're running static voltage, isn't actually that much higher than if you're running the, like, proper idle voltage settings. So I don't really care that, like, personally, I just don't care about the idle power savings that this offers, especially if you're if you're actually running, if you have videos playing or something, there's a good chance it's not going to be really idling that well anyway, just because you have stuff in the background. But Yeah, we're going to set it to 32K. And I guess if you had some random like RGB control utility with a really fancy UI, that would probably keep the CPU lit up pretty well constantly. Anyway, let's hit it with 32K. And, well, it's not on fire yet, but if we run this for long enough, it will get really, really hot. So now we're pulling over 220 amps. The voltage regulation is still absolutely just amazing. Like this is so cool. Like, I'm super impressed by this. Um, and yeah, and we're getting 1.3 volts. So yeah, you could still bump this up a bit, right? Like, I punched in 1.4 volts. We're getting 1.38 here, 1.386 there, which is fine. And then if I escape out of prime 95, our voltage just disappears because it's full. Like, it's full, like, dynamic voltage at this point, right? So yeah, override voltage mode is just like the coolest thing ever. And I feel like it's not fair for me to compare. Like, ultimately, I think I'm gonna do most of my transient response comparisons for Z490 between like regular static modes, but like like most boards have adaptive mode. But the thing is, I really don't like dealing with adaptive mode, and so now it's just like I feel it's kind of unfair that I'm going to be handing over the win for best transient response to Gigabyte, basically, because because this works so damn well. Like, you don't need LLC anymore. You just use override mode. Um, and yeah, there's still some Vdroop to it, but that's kind of the whole point. Like, you're supposed to have some Vdroop. And, I wouldn't ultimately, even if I was using fixed voltages, right, I wouldn't ever punch in more than like 1.45 volts fixed. I would just not go over that voltage level. That's a bad idea for the lifespan of the CPU. Also, on fixed mode, going over 1.45 volts gets the CPU insanely hot. If you have anything with more than 6 cores. Like, if you're on a 6 core, you can actually still deal with it. But if you're on like an 8 core or 10 core, not so much. Um, well, especially with the 10 core, not so much. But yeah, so that's basically it for this video. Man, this video turned out way longer than it needed. Well, actually, no. I feel like this video was great. Like, I like this video. Um, I screwed up some of the explanations, or more like took way too long to get through some of the explanations, and one of the analogies took me way longer than it should have. But yeah. So one, Ultra Extreme LLC is just straight up bad. You shouldn't use it. Um, Like, there's literally, like, I can't think of a, maybe if you were running your CPU for, like, max frequency validations and you literally just had one core enabled, then it might be viable. Just because if you only have one core enabled, the CPU can't really pull, like, the difference in how much current the CPU can pull from idle to full load is not that big anymore. But, yeah, extreme, like, ultra extreme, just bad. Extreme, also bad. We don't need to test it. It's not much droopier than ultra extreme. Turbo, like, turbo's not a disaster, like a complete disaster, but I wouldn't honestly, like, still wouldn't really use it. Like, honestly, I wouldn't use any of the LLC settings. Just leave it on standard or auto or normal, and use override Vcore, because override is so damn cool. And if you wanted to run static, just disable all the power saving, like power management stuff, right? Like, disable that and disable your C states, and you get full static voltage, but with like transient, like transient response like you've never seen before. Well, actually, this is not true. If you use fixed mode and you have standard LLC, you'll get the same level of transient response performance. But the thing is, you'll also have so much Vdroop that in order to get to like 1.2 volts while running Prime 95, you're probably going to have to set the core voltage to like 1.4, actually probably well above 1.4 volts. And, yeah, so your idle voltage is going to be like super high, and your load voltage is going to be like super low. And so that's not really going to be that great for you in the end. So that's actually kind of dumb. But override Vcore, like, is amazing. And like, yeah. Like, honestly, I was considering making a separate video about override Vcore, but I felt like that. I felt like that's padding for content, and I don't like doing that. Like a lot of like, I could have done that, but I don't want to do that. So yeah, override Vcore is freaking insane. Like it's a lit like it's if you don't like, I feel like Gigabyte could have done a better job describing what it does, but man, it is awesome. Like it is really freaking awesome. Um, So yeah, and I'm like we'll see. Like I still need to test a bunch of other motherboards, but there's a like I see a non-zero chance of override Vcore basically making Gigabyte motherboards some of the just straight up best for voltage regulation on Z490. Because this is just like it has no to me this has no downsides, especially because you can just disable all the power savings and then it's basically static voltage, which except without the without the transient response downsides that you'd get with fixed mode. So yeah, that is it for this video. So thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. That's how I got the 10700K. That's also how I got the oscilloscope. So yeah, thank you, patrons. Oh well, also of course there's also the AHOC Teespring store where you can pick up shirts, stickers, posters, the usual YouTuber merch, and of course that also went into funding things like the 10700K and the oscilloscope. So yeah, both of those help out. And there's links to both down in the description below. So if you check them out, I would be much appreciated. And that's it for the video. So I'm actually going to hit the stop button at this point. Thank you for watching and goodbye.